హలో ఎవ్రీవన్, పబ్లిక్ ఎగ్జామినేషన్లో క్వశ్చన్ నెంబర్ 5 మనకు అడిషన్ ఆఫ్ వెక్టార్స్ టాపిక్ నుంచి ఒక 2 మార్క్స్ క్వశ్చన్ ఫ్రేమ్ చేస్తాడు. నియర్ బై 10 to 12 క్వశ్చన్స్ ఉంటాయి. చాలా ఈజియెస్ట్ టాపిక్ ఇది. అడిషన్ ఆఫ్ వెక్టార్స్, డెఫినేషన్ ఆఫ్ యూనిట్ వెక్టార్, తర్వాత కొలీనియారిటీ కండిషన్స్, అట్లాగే పారలోగ్రామ్ లా, డైరెక్షన్ కొసైన్స్ అండ్ డైరెక్షన్ రేషియోస్, వీటిపైన కమాండింగ్ ఉంటే ఈజీగా మీరు ఒక 2 మార్క్స్ స్కోర్ చేయొచ్చు. లెట్ us డిస్కస్ ద ప్రాబ్లమ్స్ విచ్ ఆర్ ఆస్క్డ్ ఇన్ ద ప్రీవియస్ పబ్లిక్ ఎగ్జామినేషన్స్. See this question. There are 3 vectors a bar, b bar and c bar. Find the unit vector in the direction of a plus b plus c is given. మీకు క్వశ్చన్ ఇన్ ద డైరెక్షన్ అడగొచ్చు, ఇన్ ద సేమ్ డైరెక్షన్ అడగొచ్చు, లేదంటే ఆపోజిట్ ఇన్ ద డైరెక్షన్ అని కూడా అడగొచ్చు. యాక్చువల్గా యూనిట్ వెక్టార్ డెఫినేషన్ ఏంటి అంటే ఏ క్యాప్ రిటర్న్ యాజ్ ప్లస్ ఆర్ మైనస్ ఏ బై మోడ్లస్ ఏ. ఇది ఏ వెక్టార్ అనుకోండి, ఒక యూనిట్ వెక్టార్ కావాలి. సేమ్ డైరెక్షన్లో ఉండొచ్చు యూనిట్ వెక్టార్, వన్ యూనిట్ వెక్టార్ ఆపోజిట్ డైరెక్షన్లో కూడా ఉండడానికి ఛాన్స్ ఉంది. సో ప్లస్ ఆర్ మైనస్ ఏ బార్ బై మోడ్లస్ ఏ బార్ రాస్తాం మనం. మన క్వశ్చన్ సేమ్ డైరెక్షన్ అంటేనేమో ప్లస్ సైన్ వాడాలి, ఆపోజిట్ ఇన్ ద డైరెక్షన్ అంటే నెగిటివ్ సైన్ వాడాలి. ఇక్కడ ఏ ప్లస్ బి ప్లస్ సి మన వెక్టార్, ఆ డైరెక్షన్లోనే యూనిట్ వెక్టార్ కావాలి మనకు. అంటే మన ఫార్ములా ఇప్పుడు ఏ ప్లస్ బి ప్లస్ సి హోల్ డివైడెడ్ బై మాడ్యులస్ ఏ ప్లస్ బి ప్లస్ సి. ఒకవేళ ఆపోజిట్ అని ఇస్తే మాత్రం గుర్తుపెట్టుకోండి, మైనస్ సైన్ మాత్రమే రాయాలి. రైట్, ఓన్లీ యూనిట్ వెక్టార్ ఇచ్చాడు అనుకోండి, బోత్ ప్లస్ మైనస్ రాయాలి. మనకి ఇన్ ద డైరెక్షన్ అని మెన్షన్ చేసిండు కాబట్టి మనం ప్లస్ సైన్ యూజ్ చేద్దాం. ఎస్, ఫస్ట్ ఐఎమ్ గోయింగ్ టు రైట్ ద ఫార్ములా, దట్ ఈజ్ unit vector in the direction of a bar plus b bar plus c bar is, that is e cap అని రాద్దాం, జనరలైజ్ నోటేషన్. సేమ్ డైరెక్షన్ కాబట్టి ఏ బార్ ప్లస్ బి బార్ ప్లస్ సి బార్ హోల్ డివైడెడ్ బై మాడ్యులస్ ఆఫ్ ఏ బార్ ప్లస్ బి బార్ ప్లస్ సి బార్ ఇట్ ఈస్. సో దిస్ ఈజ్ ద స్టాండర్డ్ రిజల్ట్ ఫర్ యూనిట్ వెక్టార్ సిన్స్ ద వెక్టార్ ఈజ్ సమ్ ఆఫ్ ఈబీసీ. మనకు ఇండిపెండెంట్గా ఏబీసీ ఇచ్చాడు కదా, ముందు వాటిని సమ్ చేసి పెట్టుకుందాం, న్యూమరేటర్లో రాద్దాం, వాటి లెంత్ డినామినేటర్ పార్ట్లో రాద్దాం, ఆన్సర్ వచ్చేస్తుంది. హియర్ ఇన్ దిస్ క్వశ్చన్ ఏ వెక్టార్ ఈజ్ గివెన్ యాజ్ 2i plus 4j minus 5k and another vector b bar here I plus j plus k. Next c vector, that is j plus 2 times of k. Adding all the 3, we get a bar plus b bar plus c bar, that is equal to 2i plus I, that is 3i, 4j plus j, that become 6 times of j. Next, minus 5k plus 3k gives the result minus 2 times of k. a plus b plus c over. Next we need to find length of a plus b plus c. Next I am going to find modulus of a plus b plus c, that is root over 3 square value 9, 6 square value 36, minus 2 whole square value 4. రూట్ ఓవర్ ఏ స్క్వేర్ ప్లస్ బి స్క్వేర్ ప్లస్ సి స్క్వేర్ కదా ఫార్ములా. సో 9 ప్లస్ 36 ప్లస్ 4 అని వచ్చింది. రూట్ ఓవర్ 49 ఇట్ ఈస్. that is 7. Next, required vector and రాసేద్దాం ఆన్సర్. Required vector equal to a plus b plus c న్యూమరేటర్లో ఉండాలి కదా, 3i plus 6j minus 2k whole divided by 7. This is the answer. చాలా సింపుల్ క్వశ్చన్స్ ఉంటాయి, ఈజీగా సాల్వ్ చేయొచ్చు. See the next question. Find the unit vector in the direction of sum of vectors a and b. First vector 2i plus 2j minus 5k, second vector 2i plus j plus 3k is given. Sum of vectors అంటే a plus b ఫైండ్ అవుట్ చేసి పెట్టుకోవాలి. ఫస్ట్ యూనిట్ వెక్టార్ అడిగాడు కాబట్టి మ్యాగ్నిట్యూడ్తో డివైడ్ చేస్తే ఆటోమేటిక్గా యూనిట్ వెక్టార్ వస్తుంది. సేమ్ డైరెక్షనా, ఆపోజిట్ డైరెక్షనా, లేకపోతే జస్ట్ యూనిట్ వెక్టారా చెక్ చేసుకోవాలి. ఇన్ ద డైరెక్షన్ అన్నాడు కాబట్టి ప్లస్ సైన్ మాత్రమే వాడాలి. ఎస్, ఐఎమ్ గోయింగ్ టు రైట్ హియర్ ఫస్ట్ ద ఫార్ములా. యు నో దట్ యూనిట్ వెక్టార్ in the direction of sum of a and b, that is, you can write simply e cap notation, a plus b divided by modulus of a plus b. This is the standard formula to find unit vector which is in the direction of sum of a plus b. But here, by the given data, a vector is 2 times of I plus 2 times of j minus 5 times of k, and the other vector b bar, that is given by 2i plus j plus 3 times of k. I am going to find a plus b. A plus b is 4i plus 3j minus 2k. Next, length of a plus b. Length of a plus b root over a square 16, b square 9, c square 4. That is 16 plus 4, 20 plus 9, 29. So that we get root over 29. Now, I am going to write required vector equal to formula a plus b by modulus a plus b, that is equal to, here a plus b 4i plus 3j minus 2k, and in the denominator part it is root over 29. That's all. Next question. Position vectors of capital A, capital B, capital C are given, and there is a condition AB vector equal to lambda times AC vector, then find the value of lambda అంటున్నాడు. Yes, position vector of A, position vector of B, position vector of C is there. Position vector of A is denoted by OA vector. So, given data, I am going to write position vector denoted by initially with letter O. So, OA vector, OB vector and OC vector are given. They are, first one, minus 2i plus j minus k, minus 4i plus 2j plus 2k. Next, 6 times of I minus 3 times of j minus 13k it is. Next, there is a condition AB vector equal to lambda times of AC vector. So first, by this condition, since AB equal to lambda into AC, implies I can write AB vector written as OB minus OA. Next, lambda times AC vector written as OC minus OA implies what is OB here? Minus 4i plus 2j plus 2k. Subtract OA from this, that is minus 2i plus j minus k. Next, lambda times OC vector, that is 6i minus 3j minus 13k minus OA vector is minus 2i plus j minus k. Right. Now the aim is to find the value of lambda. Just simplify this. Minus 4i plus 2i, that become minus 2i. Next, plus 2j minus j, that is plus j. Next, 2k plus k, that become 3 times of k, equal to lambda times. Next, here 6i plus 2i, that is 8 times of I, minus 3j minus j, that is minus 4j, minus 13k plus k, that is minus 12k. Next, here minus 2i plus j plus 3k equal to, if you take minus 4 common, what happens? Minus 2i plus j plus 3k we get. Here you have multiple 1. There the multiple minus 4 lambda. Both the vectors are equal vectors. So on comparison, you can write minus 4 lambda equal to 1. From this I can say that minus 4 lambda equal to 1 implies lambda equal to minus 1 divided by 4. So this is the value of lambda. Next question. There are two vectors, they are collinear. Find the value of lambda and mu is given. Suppose if two vectors are collinear, then you know that the ratio of I components equal to ratio of j components also equal to ratio of k components. That is, you know the formula a1 by a2 equal to b1 by b2 equal to, a1 by b1 equal to a2 by b2 equal to a3 by b3. In the numerator a1, a2, a3 they are components of first vector. Next, in the denominator part b1, b2, b3 they are components of second vector b bar. Yes. Given that first vector a bar equal to minus 3i plus 4j plus lambda k. Next, second vector b bar, that is mu I plus 8j plus 6 times of k. These are given two vectors. You know that the condition two vectors a bar and b bar are collinear if and only if we can write the condition a1 by b1 equal to a2 by b2 equal to a3 by b3. Their components ratio same. So that here minus 3 divided by mu, which is equal to 4 divided by 8 equal to lambda divided by 6. Yes, simplifying this, we get the value of lambda. 4 by 8 here, you can write 1 by 2. So, minus 3 by mu equal to 1 by 2 equal to lambda divided by 6. Therefore, we get, first on cross multiplying these two, the value of mu become minus 6. Next, cross multiplying these two, lambda value 6 by 2, so that can be written as 3. And hence, these are the values of lambda and mu. Let us move to the next question. This is the condition for collinearity of two vectors. Next, A bar, B bar are collinear, find m comma n. A, B are given, in which there are two unknowns m comma n. The aim is to find those unknowns. You know that if A bar, B bar, two vectors are collinear, then their components ratio equal. So, using this, you can find the value of m comma n. Yes, here given that A vector, it is equal to 2 times of I plus 5 times of j plus k, and another vector B bar, that is 4 times of I plus m times j plus n times k. When two vectors are collinear, this is the condition. So that here I can write I components ratio 2 divided by 4. Next, j components ratio 5 divided by m, and the ratio of k components 1 by n. Here it is 2 by 4 written as 1 by 2 equal to 5 by m equal to 1 by n. If and only if m written as 2 into 5, that is 10. Next, solving first and last, we get n equal to 2. So, these are the values of m comma n. Simple question, easily we get 2 marks. Next, there are 4 vectors OA, AB, BC, CD. Then find OD. Observe given 4 vectors. Here, final point A. On continuation, you have next vector. Here, final position B, initial position A. Final position C, the same here you have initial position. Yes, first I am going to write given data. Very easy question. O to A is given, A to B also given, its continuation B to C and C to D. These are 4 vectors. OA is I plus j plus k, and AB 3i minus 2j plus k. BC vector, that is I plus 2j minus 2k. Next, CD, that is 2i plus j plus 3 times of k. Now, the aim is to find OD vector. See here, you have the vector O to A. Next, you have A to B continuation, and then given that B to C, and after that given C to D also. Now the aim is to find OD vector. Initially you have O, finally you have D. So here we need to apply addition of vectors concept. This is clearly polygon law. OA plus AB plus BC plus CD gives OD. Sum of all these vectors gives OD vector. So that here OD vector I am going to find. Sum of all these gives OD from the figure. Therefore, OD vector is sum of the vectors. Therefore, 3i, 1i, 1i, 2i. That is 7 times I. Next, plus 2j minus 2j gets cancelled. J plus j, that become 2 times of j. Next, 1 plus 1, 2. 2 minus 2 gets cancelled. Remaining just 3 times of k it is. So this is your required vector OD bar. And here you have to write, since OD is OA vector plus AB vector plus BC vector plus CD vector, this is by polygon law. Let us move to the next one. Define linear combination of vectors is given. It's the definition of linear combination of vectors. This is the question asked in the previous public examinations. ఎప్పుడైతే పేపర్ కాస్త ట్విస్ట్ ఇవ్వాలి అని అనుకుంటాడో అప్పుడు ఒక 2 మార్క్స్ క్వశ్చన్ డెఫినేషన్ ఇస్తుంటాడు పబ్లిక్ ఎగ్జామ్లో. సో మనం డెఫినేషన్స్ కూడా బాగా ప్రాక్టీస్ చేయాలి. See here, how can we define linear combination of vectors? That is the question. Yes, the definition of linear combination of vectors is defined by, suppose A1 vector, A2 vector, A3 vector and so on, An vector. These are vector quantities, belongs to V. I am going to write. V indicates vectors. Next, alpha 1, alpha 2, alpha 3 and so on, alpha n. These are scalar quantities. Scalar is real number. If there are n vectors and n scalars, then linear combination of vectors is defined by linear combination of vectors. It is defined by alpha 1 A1 bar plus alpha 2 A2 bar plus alpha 3 A3 bar plus and so on alpha n An bar equal to 0 bar. This is the linear combination of vectors. Alpha 1 bar A1 bar plus alpha 2 A2 bar plus alpha 3 A3 bar and so on alpha n An bar equal to 0 bar is linear. It is not 0 bar, alpha n An bar. This is linear combination of vectors. That's all. This is the combination. That's all. No need to write 0 bar. Yes, this is about linear combination. Just combination of vectors along with their coefficients. They are real numbers. Next, ABCDE is a pentagon. If the sum of the vectors AB, AE, BC, DC, ED and EC is lambda times AC, then find the value of lambda. That is the question. Sum of the vectors from the pentagon is given. ABCDE is a pentagon. So that 5-sided figure I am going to draw. A, B, C, D, E. Here it is A, B, C, D and E. Join them. AB, BC, CD, DE, EA. Here we need to find sum of the vectors. Sum of AB next plus AE and BC, DC, ED plus AC. This is sum of the vectors. It is given as lambda times AC. Lambda of AC vector it is. Now, see here, these two vectors I am going to keep in one bracket, AB plus BC. Next, these two vectors keep in another bracket, AE plus ED, and also this one, third one also, DC. And the remaining only you have AC here. This is lambda times AC. First ABBC combination in one bracket. Why? Because here the final position and here the initial position are same, so that it is very easy to add. Next, final E, initial E, final D, initial D, so that you can easily add up these three vectors. AB plus BC written as AC, A to E, E to D, D to C continuation. So finally we reach A to C, and here third vector as it is AC. This is lambda times AC. Now 3 times of AC vector equal to lambda times of AC vector implies the value of lambda equal to 3. This is the solution. Let us move to the next question. Alpha, beta, gamma are angles made by a vector 3i minus 6j plus 2k with the positive direction of coordinate axis. Then find cosine alpha, cosine beta, cosine gamma. That is the question. You know that cos alpha, cos beta, cos gamma, they are called direction cosines of a vector. So here, when cos alpha, cos beta, cos gamma are direction cosines of a vector, then you know that by the definition alpha, beta, gamma are angles made by that vector with positive direction of x-axis, y-axis, z-axis. So here we need to find those angles now. Suppose that in three-dimensional system, if there is a vector, that is suppose AI plus BJ plus C times of K. If it is a vector, then you know that the components A, B, C are called direction ratios. These are the ratios representing the direction of this vector. So that we know that if AI plus BJ plus CK is a vector, then direction ratios small a, small b, small c, and direction cosines formula. Direction cosines usually denoted by cos alpha, cos beta, cos gamma, and they are plus or minus a by root over summation a square, b by root over summation a square, c by root over summation a square it is. Yes. And here alpha is angle made by this vector with positive direction of x-axis, and beta is angle made by the vector with y-axis, and this is gamma, angle made by the vector with z-axis. This is x-axis and it is y-axis, it is z-axis. So purely this question based on the concept of direction cosines and direction ratios. Here summation a square means a square plus b square plus c square, remember. Yes, this is the concept. Here from the given vector, direction ratios a, b, c are 3, -6, 2. And from this I can write the value of a square plus b square plus c square, that is denoted by simply summation a square. Summation a square value 9 plus 36 plus 4. 9 plus 36 plus 4, that is 49. Therefore, root over summation a square value become 7. Now, there the question is find cos alpha, cos beta, cos gamma. Yes, I am going to write cos alpha, cos beta and cos gamma. Cos alpha value by this formula plus or minus a by root over summation a square, b by root over summation a square. Next, c by root over summation a square it is. What is the value of a? A is 3. Summation root over summation a square value 7. Next, plus or minus 6 by 7. And then we get plus or minus 2 by 7. These are cos alpha, cos beta and cos gamma values. Next question. Angle made by straight line passing through 2 points with coordinate axis is given. The same previous concept. Suppose there is a line, it is passing through 2 points A and B. Then the aim is to find alpha, beta, gamma. First find direction cosines of AB and then write alpha, beta, gamma. Here alpha, beta, gamma angles made by straight line with coordinate axis. So here let alpha, beta, gamma are angles made by AB line or AB vector. With the coordinate axis. Yes. First I am going to find AB vector. AB vector written as OB minus OA. And here coordinates of A given as 1, -3, 2 and coordinates of B 3, -5, 1. OB minus OA, that is clearly AB vector equal to 3 minus 1, first component, next component -5 plus 3, next component 1 minus 2. so that we get AB vector 2 comma minus 2 comma minus 1. These are direction ratios ABC. I am going to find cos alpha, cos beta and cos gamma. You know the formula, cos alpha A by root over summation A square. This is B by root over summation A square. C by root over summation A square it is. The value of A here 2 and the value of B minus 2 and the value of C minus 1. In the denominator part, root over A square plus B square plus C square. Here root over summation A square, that is A square value 4, B square value 4, C square value 1, root over 9, that become 3. So that here you have to write 3, 3, 3. But the aim is to find alpha, beta, gamma. Therefore, I can write alpha is cos inverse of 2 by 3. Next, beta cos inverse of minus 2 by 3. Gamma cos inverse of minus 1 by 3. These are angles made by line passing through 2 points with the coordinate axis. The same like previous concept. When you know the vector, those components are direction ratios. Indirectly, direction cosines means that indicates a unit vector. Why? Because we are going to divide with length of the vector. So, dividing with its magnitude, we get direction cosines. Direction cosines are cos alpha, cos beta, cos gamma. So, from that we get alpha value cos inverse of something, beta cos inverse of something. So, in that way we can find alpha, beta, gamma. Let us move to the next one. Define coplanar and non-coplanar vectors. The definitions from this topic are very important. Why? Because in the previous examinations, if you observe all the papers, twist questions are from addition of vectors only, and clearly there are different types of vectors, so that you have to prepare what is collinear vector. You have the condition a1 by a2, b1 by b2, c1 by c2, linear combination of vectors, and also you have a grip on unit vector definition, and also you have to study about types of vectors also. Yes, negative vector, equal vector, those definitions also you have to practice. But the most important things are linear combination of vectors, unit vectors, and coplanar, non-coplanar, and collinear. These four are important. See here the question, define coplanar vectors and non-coplanar vectors. Coplanar means 3 or more vectors are said to be coplanar if they lies on the same plane or on the parallel plane. Suppose this is first vector, this is second one, and this is third one. Assume that this is A bar and it is B bar. Next it is C vector. Maybe the vectors are on the same plane or on the parallel plane. Maybe they are on the parallel plane also. Yes, I am going to write the definition. Three or more vectors are said to be coplanar if they lies on same plane are on the parallel plane. This is the definition of coplanar vectors. Next, non-coplanar. Non-coplanar means they are not coplanar, so that you can simply say that they doesn't lie on the same plane. The vectors which are not coplanar, simply they are called non-coplanar. That's all. So enough to write this definition. Coplanar means maybe the vectors are on the same plane or on the parallel plane, remember. Then the vectors are coplanar, and this is about non-coplanar. So these are the questions from addition of vectors topic asked in 5th question. And they are very easy, very simple calculations. You can easily score 2 marks from this topic. Thank you.